especially in the case of alien technology, because it could be a black swan event. It could be something that affects the future of humanity, and if we behave, very conservatively, we might not last very long.
Right now, at this very moment, an object traveling at 130,000 miles per hour is experiencing the most extreme thermal conditions of its entire journey through our solar system. Harvard astrophysicist Avi Loeb calls this a decisive scientific test.
Imaginative ideas that can be tested experimentally. That's the way you make progress. You don't know something. You are putting on the table possibilities, and then you motivate observers or experimentalists to figure out which one is the correct one.
Today, October 29th, 2025, advanced observation systems worldwide are determining whether we're tracking ancient cosmic debris or the first concrete evidence of extraterrestrial technology.
For alien intelligence, alien technology, I would not waste my time in a tuxedo in Stockholm. I will try to figure it out. That's much more important than an award given by a human to a human. We're dealing with something really consequential.
Two possible outcomes. 3I Atlas either fragments in spectacular fashion, releasing measurable clouds of gas and dust visible across the inner solar system, or it demonstrates behavior no natural comet has ever exhibited. Controlled trajectory adjustments, deployed probe systems, active propulsion signatures. But our star's electromagnetic glare completely blocks every telescope's direct view of perihelion, which raises Avi Loeb's fundamental question: was this precision trajectory the result of deliberate extraterrestrial calculation?
The Oberth effect says that if you were to whip around the sun, you would pick up extra energy in the process. So we're going to watch for it. The energy in must equal the energy out. But if that's not true, if there's more energy going out than in, it means that there's energy boost coming from whipping around the sun, and that requires intelligence.
As 3I Atlas reaches perihelion at 203 million kilometers, the object experiences thermal loading of 770 watts per square meter. For natural comets held by fragile gravitational bonds, this thermal stress could trigger catastrophic fragmentation, surface area exploding exponentially, producing dramatic luminosity spikes vastly brighter than anything Atlas has shown. However, if compositional analysis suggests technological manufacture, today could produce fundamentally different outcomes. Engineered materials might demonstrate thermal resilience. We could detect non-gravitational acceleration patterns, structured electromagnetic transmissions, thermal signatures inconsistent with passive solar heating. Yet today's observation window occurs behind our star. Ground-based observatories and orbital platforms cannot acquire direct data, no confirmation, no refutation. What I'm about to reveal fundamentally reframes this interstellar visitor's statistical profile. Avi Loeb characterizes this as the Trojan horse scenario.
We have also orbiters around Mars that could check for unusual activity there. It could be a black swan event where something that looks natural at first ends up being like a Trojan horse,
External data suggests conventional comet classification, diffuse coma, extended tail, predictable fluctuations. But does the interior contain unexpected technological components? Loeb co-authored official policy documentation, urging decision-makers to develop protocols for low-probability, high-impact scenarios involving unusually massive objects moving along the ecliptic plane.
And the intelligence agencies know very well that events with very small probability have to be considered seriously because they could have major implications.
Does Atlas's presentation mask its true nature? July 1st, 2025. The Asteroid Terrestrial Impact Last Alert System flagged a new object. Initial classification appeared routine, until research teams calculated velocity profile. The results didn't align with known solar system dynamics. This object demonstrated higher velocity than anything previously recorded in observation history. Embedded in the orbital data, there's information that transforms the analytical framework. Earth maintains orbital velocity at 30 kilometers per second. Mercury achieves 48 kilometers per second. Atlas was measured at 58 kilometers per second, beyond Jupiter's orbit when detected.
And indeed, the trajectory is aligned with the plane of the planets around the sun to within 5 degrees. The chance for that at random is 1 in 500, okay? And it's moving in a retrograde trajectory opposite to the motion of the planets, which is ideal for it to release mini probes that will get into the planets.
At that velocity, gravitational capture becomes physically impossible. The trajectory confirmed the object would execute solar flyby and return to interstellar space. Hyperbolic trajectory. Atlas originated outside our solar system, traveling from the vast distances between stellar systems. Third confirmed interstellar visitor in observation history. You likely recall Oumuamua, detected in 2017, elongated geometry, non-gravitational acceleration without visible outgassing. Then Borisov in 2019, conventional cometary behavior. Atlas makes both predecessors appear unremarkable. The next section reveals why this object's characteristics challenged every predictive astrophysical model. 3 critical differentiators. First, scale. Oumuamua measured approximately 400 meters.
It was the size of a football field. Further 100 meters.
Borisov reached 1 kilometer. Atlas could span 5.6 kilometers, 5 times Borisov's scale, 14 times Oumuamua's dimensions. Fundamentally different classification. Second, velocity. Atlas demonstrates roughly double the transit speed of either predecessor, approximately 200% faster. Third, where statistical probability breaks down, approach vector geometry. Borisov approached at diagonal from similar region. Both head-on encounters. Atlas demonstrates side impact trajectory, approaching in nearly perfect alignment with the ecliptic plane, the flat disk where planets orbit. Just 3 degrees deviation. Here's the statistical detail most overlook. This represents a 1 in 20,000 probability event. Interstellar space is 3-dimensional. An approaching object could originate from any directional vector across 360-degree spherical geometry. Statistical analysis indicates the probability of something intersecting our system almost perfectly edge-on, aligned with planetary orbital planes, approaches vanishingly small percentages. Random dynamics don't explain this precision alignment. May 7, 2025. The Transiting Exoplanet Survey satellite acquired Atlas. Research teams predicted luminosity would increase 1.5 times between May and June. Actual data showed 5-fold increase. Something was producing significantly more radiation than simple matter reflecting solar energy. 2 characteristics immediately distinguished this object: electromagnetic polarization profile and premature coma formation. What I'm about to share contradicts every documented comet behavior in modern astronomy. Most celestial objects demonstrate positive polarization. Atlas registered the most extreme negative polarization in detection history. No cataloged comet, asteroid, or natural object approaches this signature. Atlas occupied position beyond 5 astronomical units when coma developed, 5 times Earth's solar distance. At those temperatures, water ice doesn't sublimate. Conventional comets remain thermally dormant, yet Atlas already displayed measurable atmospheric cloud. Spectroscopic analysis identified the mechanism. Carbon dioxide-dominated composition, 8-to-1 ratio of CO2 to water, completely inverted from every comet we've studied. Frozen CO2 sublimates at significantly lower temperatures than water ice, like dry ice producing immediate fog, which explained premature coma development, but didn't explain why the ratio was inverted from established cometary standards. Understanding what comes next reveals why research teams are questioning fundamental assumptions about natural comet formation. Summer observations detected nickel in the gas cloud. Not anomalous itself, but spectroscopic analysis identified nickel without corresponding iron signatures. Profoundly abnormal. Nickel and iron are typically bonded during planetary accretion, asteroidal formation, cometary development. When you detect nickel, you expect iron. The elements are cosmically inseparable in natural formation, except in Atlas. Substantial nickel readings. 0 iron. What natural process achieves that complete separation? Late September, data shifted dramatically. Iron suddenly appeared in spectroscopic readings. Analysis began showing conventional nickel to iron ratios. The unprecedented chemistry was normalizing, but only after months contradicting our understanding of cometary composition. Atlas was becoming ordinary, but achieving that through extraordinary pathway. Recent findings suggest the metal ratios could indicate formation processes not yet documented in natural celestial object development. Strategic observation windows. November 3rd. Atlas reaches 97 million kilometers from Venus. December 19th. 267 million kilometers from Earth. March 16, 2026. 54 million kilometers from Jupiter. Close enough for Juno spacecraft high-resolution imaging and electromagnetic analysis. Avi Loeb has publicly questioned whether Atlas might deploy what he characterizes as gift-wrapped probe systems during December approach. His Galileo project team is conducting systematic monitoring for anomalous atmospheric objects using advanced detection networks. Each planetary flyby represents critical surveillance window. Each could reveal technological signatures current systems aren't yet detecting. Today's perihelion represents the only direct observation opportunity, and electromagnetic conditions prevent direct observation. Perihelion constitutes the ultimate stress test. If Atlas represents fragile aggregate minimally held by weak cohesion, the 770 watt per square meter bombardment occurring now could induce structural fragmentation. Component pieces would achieve rapid vaporization. Systems might detect cometary outburst, unlike anything in modern astronomical history, cascading disintegration producing enormous luminosity spikes. However, if the elevated nickel abundance, inverted chemistry, extreme negative polarization, and unexpectedly early coma suggest composition beyond conventional categories, today could be producing controlled maneuvers we won't detect for weeks. Precision course corrections, separating technological components, artificial illumination, thermal emissions inconsistent with passive heating. Comprehensive understanding will develop in coming months. As Loeb emphasized, in what represents a blind encounter of interstellar proportions, we should conduct systematic observation rather than relying on limited theoretical frameworks. Today, the decisive moment is occurring. October 29, 2025. Either Atlas demonstrates behavior exactly as models predict, and we're tracking the most anomalous natural comet ever documented, or it displays characteristics requiring us to expand classification categories for what travels through interstellar space. We cannot observe directly, but evidence will emerge. Venus flyby data, Earth measurements in December, Jupiter encounter analysis next spring. One way or another, 3I Atlas will reveal its true nature through observable evidence. What began as the highest velocity object ever recorded at 130,000 miles per hour has become an active scientific event occurring right now, 103 million kilometers distant, where the decisive test Avi Loeb predicted is unfolding in solar radiation we cannot witness. When data arrives in weeks ahead, we'll determine if today's extreme thermal moment revealed ancient ice or something current models can't categorize. Either way, today represents the moment we stopped making assumptions about what moves through the darkness between stellar systems. The implications for future space observation infrastructure investment and interstellar object detection protocols could be transformative for the entire aerospace research sector.